Hi, I'm Rich with insideHPC. We're here at HPCast in Dallas, Texas, the week before SC18. I'm here with Dr. Eng Lim Goh from HPE. Eng Lim, thanks for having me once again.
Good to see you again. Rich, yes, as always. Yeah.
You know, we've been doing this series of fireside chats about
Consistently.
about HPC and trends and things. And you gave a great talk today about the current state of AI and HPC and convergence. Could you tell us more about that?
Yeah, first and foremost, right, the difference between the traditional way we have lived, which I call the top-down way, is where you build your models using rules, laws, formulas, and then you feed in the initial condition, and it does a prediction for you. So a top-down way, build model, predict. Yeah. Now there is a new and emerging way in high-performance computing where they additionally add an approach where it's bottom-up, and that is, don't build a model with rules, formulas, or laws, right? What you do is you feed it lots of examples, and then put adjustable dials, which I call adjustable dials. They are weights.
Okay.
Yeah. And as you feed enough examples, feed the first example in, you check the answer. If it's wrong, you adjust the dials a little bit.
Okay.
After hundreds, thousands, 100,000, a million of these examples, the dials get adjusted to a pretty good state for prediction.
Yes.
So now we have the top-down and bottom-up way. And I was speaking to the audience, our HPC people, our customers, to keep in mind that this new way of prediction is emerging within HPC.
Yeah.
It's been around for some time, but the surge is coming.
Yeah. And so these AI frameworks, it isn't like logic where you put in an input and you get a specific output, and if you don't quite like, you just adjust. This is a different way of computing, isn't it?
Yeah, some call it the bottom-up trial and error way, right?
Yeah.
But they say it's okay if I have enough tries, I eventually get to a good state.
Yeah.
Right. Because with the lowering of cost of computing power, the availability of examples to keep trying, this has become more and more practical.
Okay. Well,
so now we have these two ways,
Yes.
top down, bottom up, and I keep emphasizing to our HPC community, right, to stay relevant, be prepared for this new wave that's coming.
Yeah. You talked about the rapidity or how fast this is moving in AI compared to what we're used to with MPI and the traditional HPC ways.
Yes.
Can you explain?
Yeah,
that?
you caught on to that fact. Right?
Yeah.
I mean, if you think back, I've been in the HPC industry 3 decades now, right? Yeah, and I can remember the early days of MPI, how long it took to mature and accept, and then days of OpenMP, right? How long it took. But you compare that to the machine learning or deep learning frameworks that have been invested in by the internet companies. You see how they improved and matured so quickly in a few years.
Yeah.
I think mainly because of the huge amount of money they're putting into this, right? Yeah. Internet companies have a need to identify things in images, videos, right? So they have a strong need to provide services to their customers, and keep customers with them. So they invested hugely in this. Imagine $1 billion from each of these internet companies in a short span of time combined.
Right.
And that's part of the reason why you see these improvements in neural networks.
Yeah. I mean, things like TensorFlow and Caffe didn't exist 5 years ago.
Yes,
right?
And look how far they have come. One benchmark. So we use LIMPAC, right? HPCG, mass parallel benchmark, and SPEC, right? They have things like ImageNet. Right. So what they do is they take tens of millions of images, and then ask everybody, competitors, people in a contest to come in and see who can recognize things in those images within those 1,000 categories. Right. And you can see it started out making 20% error in those categorization, while humans. Well, I don't know who actually sat down and watched those 14 million images, but they're making about 5% error. Right?
Yeah.
From 20%, within a few years, it got down to only 2% error, better than humans. Yeah. So you can see it's the investment.
Yeah. So with all this money coming into it, is there danger that the HPC people be left behind as old school technologies?
That was my emphasis,
Right.
That's why I spent the first quarter of the time today putting out the landscape and giving a bit of a background as to this new way of doing things, put it all out in a single framework for them to understand, right? To bring our HPC community up to be comfortable with it, and then just treat it as a new set of HPC application, right?
Yeah.
It's just that it needs to ingest a lot of data in order to get smart enough to make a prediction.
Yeah.
We have been doing that, right? In weather forecasting, one of the big steps is data ingestion, the data assimilation step.
Yes.
Right, to get the data from satellite and other sensors, to assimilate the data, to give you the initial conditions to make prediction.
Yeah.
So we are comfortable with all that, right? It's just that the industry in this side is using new terms. And that was what I wanted the audience to just be comfortable about. Comfortable about what machine learning is. It's really bottom up.
Right.
Comfortable that from machine learning, if you have labeled data, it's supervised learning.
Right.
And one of the most popular way is deep learning, right? And it's not the only one. You have random forest, support vector machine, naive Bayes, and so on. So that's what I did. I tried to make the whole HPC community in the audience comfortable with this, and treat it as just another HPC application.
Okay, well, we don't want to scare people here, but we have exascale coming up. In the next 3-4 years, the US has put the stake in the ground, and these machines are in the process of being RFP'd and stuff.
Yes.
Is there an equivalent for AI, or are metrics not even part of the picture there?
Yeah, metrics are part of the picture, but they use a different set of metrics. Right? As we have our own benchmarks, right? The impacts of the world, they have their own. Right. Okay. And I just heard recently, it was published. One internet company, right? Their engineers came out and say, today our neural network with all those adjustable dials put together, the bigger networks they are dealing with has 1 billion weights, adjustable dials, right? Okay. And then they send in input, they adjust, and ultimately trying to get to a state they can do prediction. They say they really would like 1 trillion.
1 trillion?
Oh, that's 1,000 times bigger than what they're doing today.
But they wouldn't even try now because they couldn't solve it in a reasonable time, right?
Yes, either that or they have to commandeer a huge part of their internet data centers that they are servicing their customers with, right? Yeah. So it is not going to be surprising that if we as a community are comfortable with all this, we just approach them and say, we have a solution for you. Use our supercomputer. Right? And in fact, there are early connections right now with them. Right. We know how to build scale system. This is something that we've been doing for exascale, right?
Well, just to wrap up here, HPE I think of as kind of the forefront of data-centric computing, right? You have the machine architecture and things like that coming, and you seem to be at the perfect storm of your history of HPC and this new world together. It must be very exciting for you, Doctor.
Yes, it has been. And I must credit much of what I learned. I learned from the customers I meet. I do about 100 customer engagements a year, and this is how I start to understand the changes, right? Early on, because if you work with a customer, spend enough time with them, show value to them, they start to talk to you more about what concerns them and what they're thinking of, right? And this is the part where you learn a lot from, and if you assimilate that, right? This is how I come up with this, and hopefully by communicating what I've learned, it will help the HPC industry in this new change. Be comfortable with the terms, right? To treat it as just another set of application.
Wow. Well, Dr. Goh, I read the other day that we are the sum of the 10 people we spend the most time with. So think about those 100 people you're spending time with each year. So that's what I see. So thanks again.
Very kind of you.
Well, thanks again for sharing. I really enjoy these talks.
And very insightful questions. I love them.
Well, thanks again. We'll
see you soon again.
We'll see you soon.
Yeah.